Hello friends, how are you? In this video, today I am going to explain what is dielectric constant or relative permittivity. At first, we will know what is permittivity. What is permittivity? When two charges are placed in a medium other than air, two charges in a medium other than air or vacuum, then their force is greatly affected. In my last video, I explained how to calculate the force by the help of Coulomb's law when two point charges at rest are apart from each other in certain distance. So, if the same charges are placed in a medium other than vacuum definite, their force will be affected greatly. For example, in case of water, the force between two point charges in water is 1/80 times of charges in vacuum. That means the permittivity of water is 80 times more than in vacuum. Then what is that permittivity? I can say that permittivity is the property of a medium. It is the property of a medium which determines the electric force between two charges when they are some distance apart in the given medium. So I can say that it is the property of a medium which determines the electric force between the two charges, between the 2 point charges when they are at rest, when they are some distance apart in the given medium. So I said that in case of the water, its permittivity is 80 times than the vacuum or air. That means if the two charges placed in a medium, the force between them depends upon the intervening medium. Now let us come to the point, what is dielectric constant or relative permittivity. Just I explained that is permittivity. Now what is relative permittivity or dielectric constant. According to Coulomb's law, the force between 2 point charges at rest in vacuum, I can say that 1 upon 4 pi epsilon naught q1 q2 upon r square. This is the equation I explained in Coulomb's law. This is Coulomb's law when the medium is vacuum. Here epsilon naught is the absolute permittivity or permittivity of vacuum or air you can consider. Similarly, if in place of vacuum or air other medium is there, then I can say that according to Ohm's law, the force in that medium is equal to 1 by 4 pi epsilon into q1 q2 upon r square. So what is this epsilon? This is the absolute permittivity of the intervening medium. This is the absolute permittivity, or you can say permittivity of the intervening medium. So every medium having some permittivity. So epsilon is the absolute permittivity, or you can say permittivity of that medium or of the intervening medium. Now these two equations, if I divide the equation 1 by equation 2, that means the force in vacuum divided by force in medium, I will get 1 by 4 pi epsilon naught q1 q2 upon r square divided by 1 by 4 pi epsilon q1 q2 upon r square. This one cancel. So this one cancel. That means we got epsilon upon epsilon naught. This is called the relative permittivity. So I can write epsilon r is equal to epsilon upon epsilon naught. So I can say that this relative permittivity is the ratio between permittivity of the medium to the permittivity in free space. This is the relative permittivity, or I can say dielectric constant. K stands for relative permittivity, or it is called the dielectric constant. So it is the ratio between permittivity of the permittivity of the medium to the permittivity of the free space. So dielectric constant is the ratio between these two things, or another way I can say that dielectric constant is the ratio between force in a medium between two charges when they are some distance apart to the force between the two charges in the medium when they are same distance apart. That means, once again I am repeating, I can say dielectric constant in terms of the force. It is the force ratio between force of two charges, whether attractive force or repulsive charge force. Attractive force or repulsive force. It is the ratio between force when the two charge particles are present in a medium to the force when the two charged particles present in the vacuum, or I can write dielectric constant is equal to epsilon divided by epsilon naught. That means this is the force in vacuum, this is the force in a medium. So I can say that suppose a medium, its dielectric constant is K. For example, in a medium, its dielectric constant is K. Then the force in that medium will be 1 by K times the force in the original medium, or I can say force in the vacuum, or I can write this is force in vacuum upon K. That means if the medium dielectric constant is K, then the force in that medium will be 1 by K times the force in a vacuum or in the original medium. So this fact also can be used in case of the Coulomb's law. So in case of Coulomb's law, if the material medium is there, then I can say that according to Coulomb's law, according to the or I can say that Coulomb's law can be expressed as if in a medium is equal to 1 by 4 pi epsilon naught K into Q1 Q2 divided by R square. Here I said that if the two charged particles are present in a medium other than air or vacuum, then according to Coulomb's law, the force in that medium will be 1 by 4 pi epsilon naught K into Q1 Q2 divided by R square, where K is a dielectric constant if it is vacuum. So in vacuum, this dielectric constant is equal to 1, and if it is air, then K equal to 1.00054. Okay, and if it is water, then K will be equal to 80. So this dielectric constant, it is the property of the medium which greatly affect the force between the 2 point charges when they are at certain distance and are at rest. So I hope that you might have understood this video very clearly. Don't forget to subscribe this channel. As a result, consistently you can get our videos. Thank you.